Hello everybody, this video will describe what causes apparent retrograde motion, and in my last video I talked about what it actually is. Just a quick summary of my last video. I wrote this little simulation which shows the solar system, and we can observe, for example, Jupiter from Earth, and in this little frame down here we can see what Jupiter, what we would see looking from Earth to Jupiter. So if we start the simulation at a high speed, we can see that the apparent speed of Jupiter alternates, and that's what's called apparent retrograde motion, because sometimes Jupiter appears to move backwards, although it obviously doesn't, as seen from a reference frame that keeps the sun static. So apparent retrograde motion is an effect that is caused by the velocities of two bodies orbiting one individual body at different rates at different periods. So we need to consider a central body, for example the sun. We need to consider Earth, or whatever we want to observe from, and another body orbiting the same central body, so the sun, let's say Jupiter. So each of those planets will have an orbital period and an orbital speed resulting from this. So in blue, the orbital speed of Earth, v Earth. And we will need this in just a second, so here just the same vector again, v Earth. Then there is the velocity vj, a vector, which is the velocity of, say, Jupiter. So now we describe the entire system as seen from the sun, but if we're interested in what we will be able to see, to observe from Earth, we need to consider a geocentric system. So we need to transform the velocity of Jupiter into a system with a stationary Earth. We can easily do this by generating a v observed VO, which will be equal to the sum of Jupiter's velocity plus the Earth's velocity. So this VO is the velocity as in we could observe it in a geocentric system. Unfortunately, we can't see this. There is no way to notice when looking up in the sky if Jupiter approaches us or moves away from us. So what we can actually see is the component of this V0, let's call it V, which is perpendicular to this connecting line from Jupiter all the way to Earth. So that's just a projection in the direction of something perpendicular. I will notate this with this little hook to the vector E Earth to Jupiter. Perpendicular projection to this of obviously V0. Now that's just what we see, let's call it V. So let's see what happens and switch over to a little animation of exactly this picture. So if we consider the animation of the picture I just showed you, we can see that there are instances when the velocities add up and instances when they subtract each other. Right now, for example, they subtract each other, and we can see it appears to move backwards. Now it appears to change directions because the velocities of Earth and Jupiter add up, and we see a gigantic velocity of Jupiter. Now it starts to apparently move backwards again because the velocities subtract each other again. So that's what causes apparent retrograde motion. Thanks for watching, and see you in my next video.